So we can follow where this function is differentiable and the domain of the gradient function, which is the same thing. So function is going to be differentiable when it is smooth and continuous. So we'll check for continuity first. So you can see here that it is a continuous function. There's no breaks in it. If you can trace it from left to right with your pen without lifting your pen off the paper, then it's continuous. But obviously there's no breaks and it's continuous, so that's fine. Then we look to see if it's smooth at all places. So smooth means a gradual change in the gradient. If there's a change in gradient, it's a gradual one. So you'll see here at -5, we've got a gradient of 0, jumping to 5 or whatever, it's not a gradual change in gradient. So therefore there'll be no gradient at this cusp here at -5. And then you see again, this is going to happen at 5. So you're going to have a rapid change in the gradient rather than a gradual change in the gradient. So therefore, we can say the answer here is going to be all real numbers except -5 and 5. So when you draw your gradient function, you'll know that you'll have open circles at -5 and 5. So here, looking for where the gradient's negative. So you'll see it's two sections where the gradient's negative between -3 and 3, and then from 5 to infinity. So here, we're not going to include -3 because the gradient's 0 there. And then we're going from 5 up to infinity. And again, at 5, the gradient is 0, so we don't include that. Looking for where the gradient is positive. So it's going to be positive between -5 and -3. We know there's no gradient at -5, so it certainly doesn't include that. The gradient is 0 there, so we don't include that either. And then this section here, it's positive gradient as well. 3 not including, and then going to 5 and not including 5 either. So the two places where the gradient is 0 is going to be your turning points here, which will be -3 and 3. Okay, so if we look at E and F here. So here we got a vertical translation, either moving it up or down, so it's got no solution. So you see here, first of all, thinking about moving it down. If I move it down 9, you'll have one solution. So if I move it more than 9 down, then that'll mean I'll have no solutions. So here I can say, so here, so D, if D is less than -9, then I'm going to have no solutions. So if I'm moving it down, -9, 1, so then more than that. Alright, and then also here you see, if I move the graph up, now you're always going to have solutions if you move the graph up, because this is actually going right down to -infinity, so therefore that'll be the only answer that you've got there. So if we get another vertical translation here, see, it's got 4 solutions. Okay, so you see here, at the moment we get 2 solutions. So if you move it up, you're only going to have 2 or 1. So if we move it down here, you see, we're going to have 2 solutions to the section, that you're going to have 4 solutions. It's going to be 1, 2, 3, 4. That's what you would have, you see. So it's basically just moving it down here. And we know that this value is 3 here. This value is 1. So if you move it down between 3 and 1, you're going to have 4 solutions. You're not going to include these values, because if you move it down 3, okay, then if you move it down 3, you're just going to have 1, 2, 3 solutions, If you move it down 1, you'll have 1, 2, 3 solutions, so you're moving it down the way. Okay, so that means that I've written that wrong. So if you're moving it down, it's going to be like this.